All right. So we're rocking and rolling here. So this is the Group 7 meeting quiz. So I guess we'll start with question 3, which is one we'll need to figure out. So it's use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z negative 1.358, round to the nearest 3 decimal places. Example, if the answer is 0.8976, then you would enter 0. Okay, that's
0.8.
I really appreciate them telling us how to round. So 1.358 in the applet.
Can you open my laptop, please, Emily? Well, that one doesn't seem, that one's not that hard. We're just putting in the
No, correct. And then I guess
like,
unclicking the center, I guess. And so I show an area of 0.1745, so it would be 0.175 is what I gather.
All right, I'm going to go with that since my applet's not, I can't do the applet at the moment.
Well, yeah, no, I
Did Laura get the same thing?
Well, that's what I'm kind of waiting on. .175. She said she got that.
Okay, cool. Those are the questions I feel like it's too easy.
Yeah. No, they're just warming us up. It's nice of them. Okay, so question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means. This cannot be determined from the information given. I'm not totally following this. So, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Distribution of individual observations, the distribution of the sample means. Go to the text, I don't know.
To find that in my text. Where is it? Got all kinds of things going on here.
Do you know what that's talking about, Laura? Or are you looking as well?
Oh, pull this up. So it's saying if there's 9 drawn, which one's going to have the lowest standard deviation? Right?
It says there were 9 observations randomly drawn. The distribution of which will have the smaller deviation, basically, which will have the smaller standard deviation. So Laura said the distribution of the sample means. A is the distribution of the individual observations. I haven't even heard that terminology. You said because it's also random. Crap. The stupid comment goes away after a second. What did it say again, Laura? Because what?
It's I need to see the date.
What did you just say, Laura?
And I can't hear Laura because her audio is still not on, right? We're just doing the chat?
Yeah. It's a random drawing sample, she says.
So if it's random...
She says, yes, I'm at work. She says, sorry.
Yeah, no, it's fine. Well, I'm like, yeah, we're all crazy tonight. So But we're supposed to know which one of the random samples is the lowest standard deviation?
No, we're supposed to know, again, the question is, which will have a smaller standard deviation of the 9 observations? Distribution of individual observations or distribution of sample means?
Okay, yeah, I think it'd be the sample means would be the lower.
I'm okay with going that. Laura
Yeah,
seems
that's what Laura said,
very,
right?
very confident. She's repeated herself like 3 times. That's what
Okay, we're gonna trust Laura. She's got this. She's been right all the time so far, so we're good.
She is kind of a rock star. Okay, which of the following, question 5, which of the following results implies that the spread in X decreases as the sample size increases? Which of the following results implies that the spread of X decreases as the sample size increases? Normal distribution, the 68, 95, 97 rule, the central limit theorem, or the law of large numbers? Laura says the law of large numbers. I remember reading that in the text.
Yeah, I was going to say the law of large numbers too, so I think that is the one.
Okay. And we got, use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with the mean U equals 150.8 and the standard deviation O of 8.8. Question 6. Diana earned a score of 160 in the quantitative portion. What is the z-score corresponding to Diana's score? So we'll want to take her score, which is 160. I hate that you can't copy and paste on quizzes. Mind you, I should be able to just type out 160. I need to stop complaining. 160. And then don't we do 150.8 minus 160 and then divide it by the 8.8?
Okay, which formula is this? What's it called? Do you remember?
Laura said yes. So it's, I can't remember what the equation is called, but we do 150 or 160 minus 150.8 divided by 8.8. That's super annoying that Laura's message only pops up for like 10 seconds and then goes away.
I know, that's weird. It should stay in the chat window.
Let me see if I have a chat. Oh, hey, I have a chat window.
On the right-hand side, you should have the chat window.
Upper left. She said 1.045. I'm going to have to rerun mine because that's certainly not what I got. Yep, I just opened the chat window. That's awesome. I'll check my numbers. 150.8.
Put this on my laptop. I'm going to carry it on.
So you did 160 minus 150.8, Laura? Okay.
That's the. Oh, I know which one you're doing. Is that the standard? That's the standard deviation minus the mean over the.
Let me add some parentheses. See if that'll.
The thing.
Clean up my equation here. That helped. It'll help when I put parentheses in. I'm a dum-dum. Okay, so I got the same thing. 1.045 that one says after round. Let's see. 1.045, and it says, yeah, around 3 decimal places. So 1.045. Okay. .045 it is. Or he's probably already done the whole quiz if he's just waiting on me. Okay. What is...
I don't do it in advance. I do it on the call, so I think...
Well, I know, but she's just, you know, she's probably just going through all of them. I'm taking my time. She's probably already done with all the questions. Anyway, what is the probability that a randomly selected student will score above 160 in the quantitative portion of GRE? So I think we need to take this information and plug it into that applet thing, right? Let's see here. And put in the area 160. What is the probability that a randomly selected student will score above? Oh no, we just need to put it in and then only highlight the one side, the higher than 160 range. Is that correct? 1.045.
Okay, where's my guy?
1.045. No, that doesn't look right.
Where is this? I'm not until I have to do my class right now, baby.
How are you? Mom, how are you?
I was at Jared's concert, but I'm doing my class right now, guys. Okay. We're at number 8. It's the law of large numbers in this one.
And I'm not doing this right. Let's see here.
Okay, so what's the formula that you're doing?
Well, on this question, I don't think we're doing the formula. We're plugging in the answer that we received earlier. The 5 to the applet.
Yeah.
And I'm doing that.
Sorry, I'm just pulling up my second.
When I get the higher area, I mean, is it the 14%, 14.8%? Well, that's it. Laura's just saying right now. So it's just 14.8% basically. Okay.
This is number 7 or 8. Which one was this?
This is numero 7.
And it's 14%.
Yeah, it's
but it's 0.14.
It's 0.1480.
Are going to the 3 decimals. So 0.148.
All right.
Where's my applet? There it is. I don't have permission to open the applet. Okay. Why?
It's because they still think you're driving.
But I'm on my computer. This is so weird.
I'm just kidding.
I just I have these random things that happen to me on Brightspace. It's awesome.
Okay, question 8. A random sample of 5 students was selected to take the GRE. Their scores are, they give them to us. What z-score corresponding to the sample mean of these student scores. So are we finding the average of theirs, and then
a random sample of
we have to come up with the average and then the deviation between them all to get the z-score. Does that sound correct?
Mm-hmm.
Okay. 161.75.
Was selected. Their scores are this. What is the z-score corresponding to the sample mean? Oh yeah, this is like how to find the z-score backward.
163, 149, 153.
Okay, wait. How do you find the z-score? Oh my gosh.
So we have to take these numbers and we have to find the mean, and then we have to find the standard deviation from the mean, and then we have to do the same thing as the earlier, where we take
that's in the spreadsheet. Remember the spreadsheet that did all that? It gave us all of those. It gives you the mean, the z-score, and the standard deviation.
Well, yeah, but I mean, it's not that difficult to come up with. Just plug in the numbers and let's see here.
Well, that's true. I don't even know where I saved those stinking spreadsheets.
Actually, never mind. Mean. Is there really not an Excel function for mean? There's median. Min.
Where are my numbers? So it's 160. Go. Here we go. 160, 175, 163, 139, 130. So the mean is 160. The standard deviation is 10.049. Actually, it's 10.050. Is that what you're getting? Is the mean?
Hold on, I'm struggling. Seriously? Summit.
How can I open? Maybe the textbook.
So the mean is just going to be 160, right? So it's yet them all together. It's 800. You divide by 5, which is how many there are, and it's 160. And so, let's see here. We then take we have to find the standard deviation. Never mind. Okay. Standard deviation.
What about the dogs?
You can bring them in.
I don't want them in. I don't like the dark.
I'm still trying to open this dang applet because it's saying I'm rejected. I'm trying to figure out another way to get there.
Tell Jared one.
Then go tell Jared one. Oh. So we replace the value with the normal random variable, the mean with this mean standard.
On the dum-dum. It's STDev. Okay. Population.
So what value would be put in there though?
Well, we have to.
It says the value is a normal random variable.
Go back to the question. What is the z-score corresponding to the sample mean of these students? Is z-score corresponding?
Is it 5? Because that's how many there were. What is it? This is like probably the simplest thing ever, and I like my brain is not getting what number to put in. Is it 5? There's 5 numbers because there's 5 students minus the mean over the standard deviation.
I don't think so. When did we do z-scores? Was that lesson 5?
I don't even remember when we did them. But it's in the textbook for chapter, like lesson 7. It's sitting here. It says that to get the z-score, you do z equals value minus the mean over the standard deviation. But what's the value? Okay. Oh, here it is. Nope. Just kidding. That's not it. That's after you found the z-score. If it's normally distributed, we can consider the sample mean x as one observation from a normal distribution with mean and standard deviation. We might compute the z-score for any.
So I have a standard deviation of 10.04.
Yeah, that's what I have as well.
Okay, all right. 10.
Well,
I
it's
guess
10.05
Yeah.
because the 9 bumps
Okay.
it up.
Okay. 0.05. So the mean of that, standard deviation of that. So we're missing the number that you would normally like subtract.
Well, that's the
Missing.
mean, isn't it? Right?
Let me go to the previous question here where we had to do this. Oh, so the previous question, they give you the individual person got 160, and then we have the mean and the deviation. So in this instance, we don't have like an individual number that we're looking for. We're looking for just the z-score for all of them, I guess. So would it be the average itself? So it would be 160 minus 160 divided by 10.05. Does that make
Divided by. I'm not getting. Mine doesn't make sense. Well, you can't, because then you have 0. You can't divide by 0.
Yeah.
So I'm trying to figure out what they're saying this value is. Ay, ay, ay. Oh. Has a mean of 10 and a population. Not that one.
Score corresponding to the sample mean.
Laura, do you know what we're asking and how to answer it?
Her last response was, "I'm so lost with this one."
Oh, oh shoot.
Yeah.
Oh.
So what is the z-score? So what is the sample mean of these students' scores?
Oh, okay, wait. We did this. Okay. The mean of the random variable x with the line over is the mu. Is that mu? Is that how you say that? Mean, mu. I forget how they pronounce that little U thingy.
Okay, since the sample size is large, n equals 61, we can conclude that the sample is normally distributed.
Standard deviation of the
So
random variable
use
is this.
normal probability output to find the probability that the
The
sample
sample
mean
mean
will
is
less.
normally distributed. The mean x is 1 observation.
Okay. When is the sample mean normally distributed? Parent population normally
Value for any value of this random
sample
variable.
size is large and central theory implies the sample mean is
So
normal.
if the value is the number with the normal, the mean, what the heck is a normal random variable? They replaced the value with the normal random variable. So what's the normal random variable? The value is what? Oh yeah, where x is a normal, u is mean, is and it.
Yeah, Laura and I are just looking through the text. I'm control Fing sample mean because that's really what we're missing. We're missing the sample mean.
Okay, so since I'm not understanding the text, I mean I see it, but it's not helping me solve it. Wait, maybe this one will show me. Is if the sample size
One
and
of
the
the
sample
questions in the text is, what is the value of the sample mean? What does this say?
and we can find the area to the left. The population mean the cost. No. A random sample. It's not locked. It's to be selected, which is part of the mean. Be less twice. C score for x equals. Oh, we're trying to find. Okay. No, we're not. That's a different problem.
The
Design.
mean of the distribution of sample means is the population mean. Does that mean 5?
That's what I'm thinking. I think it's 5, but I want to see if I'm right. Like, I want this to tell me if I'm right. When the distribution, okay, to compute probably sample mean.
If the collection of all possible sample means x is also a population, the mean of the distribution of sample means is the population mean u. That's right.
Right. And remember, on Tuesday, that's how I figured out the whatever we were figuring out there, that the one equaled the other. The x equaled the sample means equal the population mean. But that would mean, okay, the sample mean is one. See, now there's so many. The terminology is so close together. It's throwing my brain off. Just because there's the mean of the random variable.
Distribution of sample means.
Because there's the population mean, the sample mean, and then the mean of the random variable. But the sample mean is one observation from a normal distribution. Oh, yeah, okay. So if the sample mean is normally distributed, we consider the sample mean, which is x, as being 1. Okay, it's one observation from a normal distribution with the mean of that and the standard. Okay, we can. So x with the line over it is one observation, which is a value. Could that be any of those? Any value of the random variable. So if it's a random variable, any of those numbers would work.
So would they all
Except
have the same?
160 wouldn't work.
Would they all have the same z score then? Is that what you're saying?
I don't know. I'm trying to work it through in my head. So that would be like, say, 175 minus the mean of 160. It's 15 divided by the standard deviation of 10.0498. Because you don't round until you get to the end. So that gives us a z-score of 1.492. And if we put that in the applet, which it won't let me do because I'm banned.
1.492, you said?
Yeah. If it'll let me in, it would be super great. It won't. Ugh! I'm not trying to print. I'm trying to just go there. Okay, 1.492. There, it finally opened it this way. So it gives us an area of 0.1357, and now I lost track of what we're trying to get. Okay, oh, it just wants a z-score 1.0. So that's assuming I'm right. I don't know. But it would have to be the same z-score, right? So that's how we could test the theory if I'm doing the theorem remotely.
Well, and I was just reading from the lesson 6, the last lesson.
Yeah.
So let's see. We only observed. It says in this section, it's talking about like South African women or something. So it says we never saw the distribution of sample means. We only observed one sample mean, X, even though we do not get to see the distribution of all possible sample means. Since the sample mean size was large, we can be assured that the sample mean X can be considered as one drawn from a normally distributed population of possible sample means. That's confusing. Simulation. So you took just one of the numbers.
Yeah, I just took one of the numbers and plugged it into the z equals value minus mean over standard deviation. But when I did that, it only, I mean, one z-score is, you know, they're all different.
Yeah.
Doing that. But is that can that even work? That is, it has a mean of 0 and a standard deviation of 1. After we compute this, we just have to find that around 6 millimeters over. Okay, that's finding the area.
Yeah, because when I did the 153 minus 160, that's a completely different z-score.
Yeah.
It's 0.696.
Hey, get out. Shh. You're loud. This isn't that hard. This has got to be like the most basic thing, and my brain is like,
Yeah.
No, X is the mean of the random variable is, but it can't be because that's the excuse me, random variable. Oh, I wonder if it's in the video. Did you see the video that's on the home? I didn't. I wonder if it's in here. All right, talk faster, buddy. We're trying to find. Here is the going back to lesson 5. Find the z-score. What is the probability of the pregnancy that last less? We don't need a probability. We just want to know the stupid z-score. The value of 260 into a z-score. It's still a probability. 260, the value 260 minus v 66 divided by the standard deviation, which is 16. If we solve for that, we get a z-score of negative 1.375. Put it into the app. Well, that's what I did. So, for instance, the length of human pregnancy it's normally distributed. Okay, so this is an example. It's a sample of 30 pregnancies. What is the? What is the mean standard deviation? Oh, okay. So when you have a random sample, which is what we have a random sample of 5.
Yeah.
Then the random, okay, so the value of the random sample equals the population mean, which equals, so we know that the population mean that's the 160.
Yeah.
Right? Okay, so we have that. And then the standard deviation of the sample thing is equal to the standard deviation over the square root of the sample size. So it'd be the standard deviation of 10.0498 over the square root of 5. I think.
So 25.
So it'd be, I don't know what how can you do the square root of 5? You can't. It doesn't have a, that's throwing me off. You can't have a square root of 5. Where's my square root button? Hey, where is my thing? Scientific, but where's? Okay, you can't take a square root of 5. It doesn't have one. Well, it's not even. But this is what he did. Okay, I'm gonna follow this. Oh, that was just to get the standard deviation. We already know that. No, I know how to get the standard deviation. How do I get the z-score though? Okay. Wait a minute. There's data up here that we weren't looking through. Holy fudge sickles. Okay. Oh. Our standard deviation. Okay, the mean is 150.8. Not 160. So, okay, that's what we're doing that wrong. Okay, so because we're supposed to be using the data above question 6 to answer question 8. So if we have a random sample of 5, the population mean is 150.8 and the standard deviation is 8.8.
So you're still doing, so you're doing 150.8. So you're doing, it's going to be the same as number 6 then.
No, but because we're supposed to use the same information. Why is my sound on?
But their mean of the 5 students is 160, which is what Diana earned. She earned 160. Does that make sense?
Well,
like I get what you're saying. So wouldn't we just be taking those 5 scores? So just so you know, I can barely hear you. Your mic is like mute, is muffled or something.
Yeah, it's not letting. I'm gonna join through my computer. And I'm gonna just rejoin the call because it's.
And I can't hear anything you're saying right now.
Can you hear me now? If I hold it, I don't know if you can hear me now.
There you go. That's better.
Okay, I'm gonna still join again because I don't want to hold it up to my ear. But
So you understand what I'm saying, right? So wouldn't we just be taking those 5 students and taking their mean at that point?
I don't think so, because he didn't end the example on the video, so I'm thinking we're supposed to use the mean for the population mean, not their individual averages from the sample.
Well, we're considering them a group, right?
Yeah. Okay. I'm going to. Okay. Am I in speaker? Oh, shoot, it's still being done. It didn't hang up.
So what I'm trying to say is we have these students' scores, and we're considering them their own kind of group or sample, right? Which their mean is 160. And the previous question was question 6, where Diana earned a score of 160. Like, wouldn't it be the same z-score?
It's, well, it's, okay, where is my quiz now? Pages everywhere. Our score. Oh, I see what you're saying. It would be if the z-score. Well, that was
all we're wanting is the z-score of this group of students.
Right. So we need the z-score for the sample mean, which when he did this on the video, he showed that the standard deviation for the whole population was 16 days. The mean of the population mean is 266, and then the X value. Yeah. So, okay, I see what you're saying. So we take the random sample, the mean of that minus the population mean of 150.8, right?
Yeah.
Or you're saying?
Well, that's what I'm saying.
Yeah.
I don't know
Okay.
if that's right.
I wasn't getting that.
If that is right, then it's the exact same as when we just did Diana's score of 160.
But the standard deviation is 8.8 because we're not going to take the standard deviation of the sample. We're going to take the standard deviation of the population.
You're right.
Yep. So it'd be 1.045 is what I got.
Okay, let me throw that in. It was 10.05, right?
No, it's 8.8, the standard deviation.
We're using the group standard deviation or the standard deviation of just those 5 students?
The group standard deviation.
Well, then wouldn't it be the exact same as question 6?
That was 1.045, right?
Yeah. Because I mean that was the formula for, or that was the calculation for question 6, was we take her score of 160 and we take the group standard deviation of 150.8 and the group mean. I mean.
Yeah, I see what you're saying. Because if we're using it as a group, then we're going to take the group standard deviation, not the population.
Yeah, that's what I'm saying. So instead of the 8.8, you take the 10.05. Again, I don't know if that's true. I think it sounds good. The other way would be just the exact same question as number 6.
Right. So it'd be 0.915 is what I have.
Okay.
That makes sense. If we're treating the group as one individual, like the question 6 was one individual, so we're treating this as one individual. I don't know. I'm not 100% sure which way, but I like the thought process, so we can go with that.
It was 10.05, right?
Well, it's 10.0498.
So I got 0.915. That's what you said, right?
Yeah, that's what I got.
That's the only thing I can think of.
Oh,
otherwise
okay.
Otherwise it'd be the same question.
Yeah.
Since you know about my piercing, let us talk a little about my tattoo.
What did you do?
Before,
I'm in a
before he
call.
tells you his tattoo.
I'm in a call.
We need gas money for tomorrow because he's taking the van.
I know. But, oh dear. That looks weird. And what is under me? Oh, it's a dog. Yeah, that's great. Okay. I have to.
Can I see the tattoo? What is the tattoo?
You want to see it?
Show me the
I'm just kidding. I don't need to see your tattoo. That's just,
It's not even a tattoo. It's
I mean, it is a tattoo.
well. Okay, I can.
You can talk about this later.
Yes,
okay,
I can talk
so
about this later.
question 10. Laura, are you still listening? Are you still with us?
I don't see Laura on the call anymore.
Oh no, Laura left. Yep. She gave up on us.
Ammon! What? Did you want gum? I'm not yelling across the house.
So question 10. What is the shape of the sampling distribution of the random variable x?
What did we get for 9?
9.915.
Wait, I thought that was 8. Shoot. Right?
Oh, yep, you're right. No, you're right.
So now we need to know the probability, which is the applet.
9.915. Okay.
915. So if we put that z-score in.
Probability that the 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem.
So the probability is who will have a score over. That's the blue area on the right.
Yeah.
The probability is 0.9275. That's the area. Oh, hold on. That's, ouch. It's 0.4637. That's what I'm coming up with. Than the mean achieved by the students in the previous problem.
What is the probability that five randomly selected students will have a mean score that is greater than the mean?
Yeah, because the mean in the last one got this z-score, which was plugged into the applet. And then if we take out if we only highlight the right side, that's the probability of higher than the mean that we input, that z-score. So 0.915. Was it 0.915 or 0.0915? What did 0.915? Sorry.
0.915. So the
Okay.
area on the one side is 18%, right? 1801.
0.1801.
So don't we have to take that 0.1801 and do something with the other answer, which was what?
I don't think we have to do anything to the other answer. Do we?
Well, they're saying something about the previous problem, right? So what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Right, but that would be over that mean. I mean, that z-score. Right?
So that area was the 0.148, right?
0.1801.
For number 7?
Oh, sorry, number 7.
Isn't that the one they're comparing?
But number 10 is still comparing again. So it's not. So we don't have to know.
Well, number 9. Run number 9.
Oh, sorry, I'm at 9. I just was scrolling.
No, you're fine. You're fine.
Greater than the mean achieved by the students. So, because if we know the z-score of the random sample, then we can find out the probability of. So, if they took 5 additional random students, what's the probability that they would score above the average of the first 5? Well,
Okay.
Since we use the z-score for the first 5, whatever that area is the probability whatever the area to the right of the z-score is the probability that anyone would get higher than that mean, right? Well, that sounded convoluted. But I think it's just the 0.1801. Because that's the probability of anyone getting higher than the mean that the others got. Since we use their mean to get the z-score.
Okay.
That's what I think.
I'm with you. Okay, so 0.180.
1. I think we're supposed to put 4 in there, so I did 0.1801.
Okay. 0.1801. Okay.
And
so we've got, suppose, use the following information. Suppose the mean GPA of a BYU student is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn.
that's a large
What
number.
is the shape of the sampling distribution of the random variable, which represents the sample mean of 81 students selected? Approximately normal, right?
Yeah, because it's a larger number.
Yep. Okay. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So I think this goes back to the one that you were talking about where you do the square root equation, probably.
Yeah.
Because I think that was. Oh my gosh, we still have another freaking 5 questions.
Okay. It's in here. Okay. What is the mean of the distribution of the sample mean? Okay. What is the mean of the sampling distribution for all possible samples of 81 that they could be drawn from the parent population? So I wouldn't take them personally because they might take it away from you. Just my thing. Are you leaving now?
Yes.
Okay.
Well, maybe not. Now I don't know.
We assume since at first we compute the z-score. Okay. Well. Okay.
Why would they take it away?
They might not. It might be fine. But it's either yes or no. I don't know what they're gonna say. But and you're coming at like 3 a.m. Saturday morning, right? Hey, you did not kiss me goodbye. Hey.
Hey, you just told them I might not let me have my hat.
That's not me deciding that. Okay, have fun. Don't die. Don't do anything stupid either. All right. Review the pattern.
What is the mean of the distribution of the sample mean? So the sample mean is.
What's the mean distribution of the sample mean for all possible samples of 81? No, it can't be that. That's not going to make sense. 80. We're done using that other information. So we know that. Okay, so we know that the mean is 3.5, the standard deviation is 0.7, and the random sample is 81. So if we did that one formula, like you were saying, value minus mean over the standard deviation, would that work? No. Standard deviation. Wait. We already know the standard deviation. We don't need to find it. Going back to the
There's not just 16, but 16 divided by the square root of our sample size, because that is our deviation of the distribution of sample means. Let's get 2.050 per 6 days
Gotcha. But
is about 2%. Okay, so now let's go through
distribution of
another
sample
problem
means.
here with the distribution. So this is dealing with the what is the mean, the standard deviation
What is the mean of the sample means heart rate?
distribution of sample.
Okay.
Where if we have a mean heart rate of 80 and a standard deviation of 16.5 days, suppose we take a random sample of 10 students, what is the mean standard deviation and shape of the distribution of sample mean heart rates for a typical college student based on a sample of 10 students? So the mean of the means, mean of all sample means, is equal to the population mean, which is 8 beats per minute.
Okay, so the mean of all sample means is the same as the population mean, so that's 3.5. So the mean of the sample means is 3.5.
That's it.
Yeah, that's what he just said. He just
I
said.
mean, that makes sense. I mean, that's kind of what I was thinking. Like,
Yeah.
wasn't it the same?
All right. Yeah, we'll go with that because I mean, that was like quote verbatim. The mean of all the sample means is the same as the population mean, which is 3.5. So,
Okay.
I guess.
What is the standard deviation of the distribution of the sample means? Sampling distribution for all possible samples of size 81 that could be drawn from the parent population.
So this one is where we do over the square root. So we have the standard deviation of 0.7 divided by the square root of 81, which is 9. So 0.7 divided by 9, 0.07777777. So it's 0.078.
Hey, I'll take it.
I'm just.
0.078, you said?
Yeah, 0.078 is.
And that was the square root of 81, which is 9.
So it's 0.7, that's the standard deviation, right, of the population. A standard deviation is 0.7. So you take the standard deviation over the square root of the sample size, and that gives you the sample distribution standard deviation. Or yeah, I think they said standard deviation of the sample, but anyway. Okay, what is the probability that the mean GPA for 81 randomly selected Idaho students will be less than 3.3? So now we have to find the z-score. I already forgot how to find the z-score. That's so terrible. Just did it. All right, where's my stupid applet again? There it is. Okay. So we need to find the z-score and then plug it into the applet and get the probability. Well, we know the 3.3 with so it's the value of 3.3 minus the mean of 3.5 is negative 0.2 divided by the standard deviation of 0.7 is negative 2.85. 257. So the probability of 81 randomly selected students will be less than 3.3 is 0.0043. That's super low. That cannot be right. What is the probability of the mean GPA for 8? Oh, actually, that seems right. If I think about it, if the mean across the population is 3.5, then you're not going to find too many that are below 3.3 because the average is pretty high at 3.5. That still seems awfully low. That can't be right.
So what does the mean distribution of sample means for all possible samples?
Percent. That doesn't make sense.
So I was taking 3.3 minus 3.5.
Yeah.
And dividing by the deviation, right? Which is...
Yeah. Hey, I got a totally different answer this time. That's what I did.
3.3 minus 3.5.
It's 0.2857, not negative. Okay. That makes a lot more sense. 39%. Okay.
7.
0.38.
And then you put that answer in. So I got, when I did that, I got 0.286. Is that right?
Yeah, well, I don't round up until I get to the very, very end.
Okay.
But so it's 0.2857. So yeah. And then my area is 0.3874. So that's the probability. So it's 39% probability.
.3874.
Yeah.
That'd be 38%, wouldn't it?
Huh?
0.3874, wouldn't that be 38%?
Well, except the 7 will make the 8 round up to 9, so it'd be 39%. But we're putting it in as a decimal, so we don't need another percent. I'm just.
Well, I know, but in context of the question. So the question is, what is the probability that the mean GPA for 81 random select BYU students will be less than 3.3? Okay, that makes sense.
0.387. But in my head, so like I just try to think of it in my head. Does that make sense? In like, does 39% make sense? And it
Yeah,
does.
it does.
You know? So
Yeah.
I don't know.
And
'Cause I
so
don't
it's round to 3 decimals, so it's 0.387.
Okay, and then the next question is the opposite of that. So all we have to do is change our applet to over the 3.3, the z-score, I mean. It's the same.
What's the probability that things will be greater? It'd be the same, right?
Mean GPA for 8 rounds.
Because aren't you just highlighting the other section?
Yeah, so that middle section under the bell curve, the normal, that doesn't go into it. We only do over the z-score and score. So it's, yeah, it's
but it would
same.
be the same.
It is the same. It's 0.3874. This is when I question myself. It's the same.
Yeah.
But it wasn't, in the other quizzes it was, wasn't it? When they had what's over, what's under, it was the same. Well, okay, hold on though. Our z-score came out to negative. So would we do anything over the
one side is negative. The one side is negative and the other side's positive.
Right.
On all of them. That's normal.
But the probability that they're going to get over a 3.3 so if you think of 39 plus 39, that 78% would get over or under 3.3, and then the remaining 22% would get from 3.3 to 3.5.
It's the same problem. You're just highlighting one side or the other, and the answer is going to be the same.
Yeah. Okay. I'm going with it. All right. Wow. Bo's 185 pounds. The previous value was lower, but was raised after tragic weight. The standard deviation of passenger weights is 26.7. The weights of a random sample recorded. The sample mean was 177.6. Find the probability that a random sample of passengers will have weight that is extreme or more extreme than was observed in the sample. As mean lower than most users also that are as far away from the mean as ours in the positive direction. So as extreme or more extreme means that we're not only interested in the values that are lower than the ones, but also values that are as far away from the mean as ours in the positive direction. Okay, let's just start from there. So if we want to pay Okay, that's extra information we don't need. The standard deviation is, okay, so we need to know the mean of 185. The standard deviation is 26.7. The sample mean is 177.6. So don't we do the same equation we just did? We're going to take the sample mean of 177.6 minus the population mean of 185 over, we divide it by the standard deviation of 26.7.
Yeah, I just hate the question because of the wording.
I know.
The United States Coast Guard assumes. They assume that the mean weight is this.
Yeah.
177.6, 185.
277. That's extreme. That is as extreme.
What was the deviation? 27 pounds?
26.7.
So I get 0.27715. Is that right?
Yeah, I mean, yeah, I got negative 0.27715, which goes both ways. But then we have to find the probability, which is 0.3909. Except find the probability that a random sample will have a weight as extreme or more extreme above or below. This note is like throwing me off a little bit because we're not only interested in values that are lower than the ones, but also as far away. Doesn't that just mean we're going to use both sides of the, we want to know the ones above and the ones below?
Let me go look at it again. Okay. As extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. Yeah, that's just confusing.
Yeah, it's just.
Okay, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Yeah, I mean, that's what it sounds like. Sounds like you're highlighting the two sides, and that's your probability.
Yeah. Okay, I submitted to see if I got it wrong, and it's wrong, so that's not that one.
0.78 is what you had? 78%?
Yeah, 0.1818, so I rounded it to 0.782, and that's incorrect. So is 14. So the one, 13, 14, and 15 are all wrong, and so is 8, 9.
That sucks.
The group scores. What? So we did something wrong on him. So as it is now, the score is 70% on the quiz. So I mean, it's not. I mean, it's a C, but it's still.
Yeah.
But I'm a little bit unclear. What is the probability of the mean GPA for 8? So
Missed that one with the 5 sample students.
Both correct. It was just the probability that we got wrong on 13 and 14. So we're doing something wrong on the probability section because we got the standard deviation right and the mean. It's just the probability section. So So, 13, 14, and 15 had 0.387. And I got point.
Well, what I think I'm going to do is I think I'm going to take it offline and try to see if I can figure it out.
Yeah, so I'm thinking I just kind of want to play with it and see if I can figure out what happened, what I got wrong. Because the last one's got me stumped. I'm like not sure what they're doing with this extremes business. But
I thought that I was pretty confident in 13, and then 14, I guess we thought it was just the opposite. That's the weird one.
yeah, because what yucky. Because it was the 3.3 minus the 3.5 divided by 9. That's not it. 3.3 minus 3.5 divided by 0.7.
Mm-hmm.
Negative 0.28. And the question is, will be greater than 3.3. So that was, what's that one about? Yeah, I'm not sure. I might have to just play with this a minute because
Yeah. That's what I'm going to do. I'm going to go ahead and end this, and I'll post it in the group chat.
If you're able to, if you get a right answer on one of them in the next 20 minutes,
yep, we'll do.
Email it and we'll get it. I do not know where my Hangouts. Shoot. Where's my Hangouts? It's not here. Okay, I'm just trying to find it to exit the call and it's not.
Well, I can just exit the call.
Found it.
So,
Found a lot of apps that would
all right. Have a good one. Hopefully one of us can figure it out.
All right, thanks.
Bye.
See you.